Hi everyone. This video is continue from the previous video, question 2, which differentiate the function involve this exponential, trigo, and logarithmic function. So this is a question 3. I have 4 example here, A, B, C, and D. Let's look at the first question. A. We need to differentiate this function f(x) equals to sine ln x. I will see this function as a two-layer function. The first layer is a sine, and the second layer is a log. So I'm going to differentiate it in this way. Differentiate the first layer, which differentiates sine, you get cos. And the inner function, which is my second layer function, I will just copy it down. And done. We're going to multiply by differentiate the second function. Okay, the second function differentiate ln x, you get a 1 over x. Then we have done our differentiation. Just simplify it. And for question B, log tangent x. Again, I'll see this as a two layers function also. This is my first layer, which is my log, and the second layer will be the tangent. So the f prime x will be differentiating the first layer function, which is a differentiate log. You will have a 1 over tangent x. All right, 1 over, as if that this is your x, differentiate log x, you get 1 over x, right? So 1 over x, the x you substitute with the inner function, which is tangent x. And then multiply by, differentiate the inner function, differentiate tangent, you got secant square. Then simplify it, secant square x over tangent x. Or you may also simplify this. To secant square is a 1 over cos square, and divided by tangent. Tangent can convert into the sine over cos. So this one will be over tangent. So multiply by cos over sine. Just find the reciprocal of the tangent. And the power of 2, the cos x, and this cos x can be cancelled off. So what do I left? I only have 1 over cos x multiplied by sine x. Alright, you also can leave your answer in this form or in this form. Both we accepted. And for question C, we have a sine x multiplied by log x. So this is a sine x multiplied by log x. So I'm going to take this as my u function, and this is my v, and I'm going to apply the product rules. Alright, so just write down your u. U is equals to sine x, then get your u prime. U prime is cos x. And if your v is a log x, then your v prime is 1 over x. If you've done this, you can direct proceed to the product rule, which is a v u v prime plus a v u prime. Substitute what you have here. U is your sine x, and the v prime is 1 over x. Substitute in, and the v equals to log x. U prime will be cos x. Then simplify your answer. You have your sine x over x plus cos x log x. For the last question in this video is cos x multiplied by log 2x plus 1. Again, this is a function, cos function. We multiply by a log function, and we take this as a u and a v. Again, we are going to apply the product rule because this operation between these two functions is multiply. Then find your f prime x, get your u and u prime. U will be cos x, and the u prime is negative sine x. V equals to log 2x plus 1. Alright, and the v prime is differentiate this function, you'll get 2 over the function itself, you have a 2x plus 1. Alright, so this is the formula to differentiate the log. And to get your f prime x, I'm going to use this product rule. U v prime plus v u prime. U is your cos x, multiplied by v prime will be 2 over 2x plus 1. Plus v is your log 2x plus 1, and u prime multiplied by negative sine x. Okay, then now we need to simplify. 2 cos x over 2x plus 1 minus, because positive multiplied by negative, you got negative. Negative sine x multiplied by log 2x plus 1. So this is the last question. This is the question 4. Now we need to use the quotient rule formula. Show that the differentiate this function equals to this. The answer is given over here. So we are going to differentiate this function ex over sine x. Then we'll take this as your u function. This is your v function. Write down your u first. U equals to ex. Then your u prime is equals to ex. Then if your v equals to sine x, v prime will be equals to cos x. Substitute in to the quotient rule, which v u prime minus u v prime over v square. Your v is sine x multiplied by u prime, which is ex, minus u is ex multiplied by v prime, which is my cos x, over v square. We have a v equals to sine x, means we have a sine square x. Then after that, we'll simplify it. Alright, let's see. They want us to prove until this, meaning that we need to factor out the ex. Factor out the ex. First term, you have your sine x minus cos x. And the denominator is your sine square x. So we have proven. Or we have shown. We have shown the statement. Okay. Thank you.